This is the main hammer in the shop. That knock that you heard right there has become a major issue. Now, we've actually gotten away with running it with that knock. It only happens at startup, and as long as it's not happening while the hammer is cycling, you can kind of get away with it. But unfortunately, it's become a major issue because the other day I was running the hammer and it got stuck in the upright position. And so it's time to address this cushion plug issue. So we're going to pull these parts and either rebuild the cushion plug and or the bushing. But first we have to disassemble the hammer and see what's going on. These are precision parts, so we're going to use blankets to protect them as we pick them out of the machine and make sure they don't get scratched up. So we pulled the muffler, which is in two pieces there. We just got done pulling the ram cap, and the cushion plug bushing is down here. These are the inner ram rings which seal the inner part of the ram. And now I'm going to climb up here on the ladder. And here's a rare look down inside of a 3B. And you can see that guy's our culprit, the cushion plug in the bottom. So now what we need to do is make a bar. Going across here, we'll run some bolts. This is what this is for. You put a bar here and then you can pull the ram that way. But it's too hard to see what's going on with that cushion plug yet, but we'll check it out. Now, this 3B was manufactured in 1929, so it's almost 100 years old. But these hammers can run thousands of hours without rebuilding any parts, but who knows how long it's been since the cushion plug and the bushing were rebuilt on this hammer. I don't know. We've put hundreds of hours on this hammer since I've owned it, forged a lot of cap rail, and it's time to address it. So we made that plate to span those bolt holes, which is designed to do. Now pulling it out with the chain hoist, coming up slow and steady. All right, so as soon as that flange clears, Jared, get hands on it so it doesn't smack the side.
It's pulling it pretty even. Should have took the die off just to minimize the weight, but.
I'm not entirely new to rebuilding a Nazel power hammer. When I first got my 2B, it wasn't running at all, and it needed a complete rebuild. So I'm familiar with these hammers. I'm familiar with the parts and some of the tolerances, but I have some friends I can also reach out for some of that information. But we're going to learn a few things on this one and a few things that surprised me, starting with the cushion plug. It was a different style than I thought it was. And then there's also been some major modifications made to the ram cap and the inner ram guide. So now that we have this apart, we can see what's going on, and we have two major problems. Number one being this cushion plug, which is supposed to pull out the bottom of the ram, has been welded into place. You should just see a seam there. So that's been a major modification, but that's not even the half of it. This usually is rounded, and this is one piece casting. You can see it's been re-rung, but this all down to here would be a one piece casting. Someone has done a major modification on this, and the cushion plug bushing, which is bronze, you can see inside of there, and looks to be in good shape and feels to be in good shape, but they made this cap to go on the end with these Allen screws, which is a pretty good fix, but they took a center punch and punched around every single cap head screw to keep them from backing out, and
it worked.
While that's a great fix, it makes it pretty much impossible to pull this cushion plug. Because I don't think you can get it out from the top, because I think it's trapped. I think what they've done is they've trapped it between this casting and this piece. So whatever shop this hammer was in, it had some major machine capabilities, because I don't know if I've ever shown this, but this is the most impressive modification that's been done to this hammer, is they turned the gear teeth off of the main flywheel. That flywheel has to weigh close to 1,000 pounds, and there used to be gear teeth because this was gear driven. They turned them off and they cut 3 pulley grooves in there, which is a beautiful, don't get me wrong, this is a beautiful fix, fantastic fix, but yeah, I mean, obviously a major shop this was in to have the ability to turn that 1,000-pound flywheel, because that does happen. You can see these teeth suffered major damage on the 2B, and what I did was I converted it to this belt drive, which drives off of the main flat, and I've been able to do that by using a single banded 4 V-belt pulley that runs on the 4 V-belt sheath up top, and there's enough surface area on all, wrapping around there with all of these 4 points of contact, that there's no slipping and no problem. So this has also been a really good fix for many years. Run it a couple thousand hours like this, and then this is even better, because now you have all the surface area around the belt. But yeah, this hammer has seen many modifications. So that's been modified, and that's been modified. But these are kind of a rare look at these parts. This is obviously the ram. This is the other thing that has really impressed me about this machine. 95% of them that you see, this has been cut and rings put in here, and this is original. This has never been touched or re-rung. This is original, how they had them from the factory. There'd have been about 1,000th clearance between this and the walls of the main bore in the hammer, and I just so happen to have an original 3B blueprint, and you can see those oil rings that were cut originally. So this is how it was designed from the factory. So, by the way, I'll try to do a slow pan on this print. This might help somebody. You can pause it. It's really faded. This was the first iteration of the cushion plug, which was straight, and then this was the later one, which had a shoulder, was solid, and then they drilled into it so that the top was hollow. And most of them that I've seen had a nice chamfer cut on the top. You can't really see that on the drawing. 8.5 inches long is what the original spec, and that's really important, because if that's too long, it makes the hammer stroke shorter. I didn't have that information way back when I rebuilt the 2B, and I had to figure out the length of the cushion plug on the 2B, which was a major pain in the butt back then. But anyhow, kind of up against it on this. We shall figure it out.
So I went to work on the ram, taking a die grinder to carefully die grind out the weld that someone put in there. These were designed to be pressed in and held in with the die. The die would seat that up in there, and someone decided to weld this in. Now, I had a lot to learn, as I would come to find out, because I was assuming that this style plug was the same as what was on the blueprint. So I thought that this would press out from the bottom, but I had a lot to learn on this one. Again, this is the hard part about working on some of these old machines, is a lot of times they've had other machine work done on them. They've been modified. Things aren't the way that they should be or the way that you think they are. So you really have to use a lot of caution and a kind of experiment to see what's going on. So this is my first time, heavy into this side of the ram. You can see I'm trying to drive that plug out there with the battering ram, and that didn't work. I die grinded it 3 times and tried to push that plug out, but we finally realized we're going to have to take it outside to the 150-ton press and press that plug out. There's about 2 1/4 of an inch that holds it, so that's a lot of surface area, a lot of friction, and sometimes you just need the tonnage of a big press. And thankfully we have one that has enough throw in the ram of the press to push this out. So now at this point I still think that this cushion plug pushes out from the bottom.
It's the moment of truth. We've done everything we can to get this cushion plug out. Let's see what happens when we put 150 tons of press behind it. Again, with doing work on these old machines, this is a lot of the work that you have to do. Machining the actual parts takes a lot of skill, but kind of minimal time compared to pulling the parts, disassembling them, and assessing what's going on. Now, I took this 150-ton press and pressed against the plug, but it just didn't feel right. Now, I took a couple light presses. I didn't use all 150 tons, but again, it just didn't feel right. So I've learned over the years to stop and reassess, and we are going to quickly flip this over and try pushing the plug out from the other side. And as soon as I touched it from this side, I thought I saw it move, but again, I'm going pretty ginger, not using all 150 tons. And I'm just trying to feel what's going on. And it did move slightly. I couldn't quite tell. It only moved a couple thou. But then I pressed a little bit harder, and you can see we finally got the cushion plug out of the ram. Now again, this part is really critical. When the machine's running, it helps create an air suction cushion at the top, and it prevents the ram from smacking and kind of destroying itself while it's running. So we were pretty psyched to finally get this thing out. So now that the ram is taken care of, it's time to go to work on the inner ram guide, which has the cushion plug bushing on the bottom. And we assumed that we couldn't unbolt that plate on the end, but actually with a cheater bar and an Allen wrench, we were able to unbolt that. So we are going to take the inner ram guide out also to the 150-ton press and press that bushing out. Well, I would have lost the bet, but we were able to unbolt this plate on the end holding this bushing in. So now we're going to press the bushing out as well. So we're going to redo the cushion plug and the bushing. Jared machined a custom pin to go in there and line it so we can press it out. So we'll get all this set up and we'll see what the press does. So we had to put the inner ram guide under the press, but also on top of a couple rings to give clearance to press this bushing out from the top. And it pressed out really quickly and easily, not nearly as hard as the cushion plug itself. But then we took these parts back, put them on a table to protect them. So there's the cushion plug on the left and the bushing on the right in bronze. Here's the special piece Jared machined so that we could press that bushing out without damaging it. That just fit inside and gave us a shoulder to press on. Here's the end of the inner ram guide where that bronze bushing presses into, and then the cap goes on. Taking this and boring it, cleaning it up. It's like 2 thou oval. Jared checked that. I think we should just reuse this. We took our time taking it out. But making a new one of these, Mark Krause said these were 8 to 10 thou undersized from this. So I'd like to make one that was, you know, 8 thou under whatever your final bore on this. 9 1/4 was turned out of a piece of 2-inch round, and he said to use like A2 for this, so that's the only material we might need to get.
So yeah, those are some notes on my plan of attack. But again, these hammers are so critical to our workflow and our processes. We have to get this one back online soon. So I'm hoping we can find a good solution to getting these parts done and machined. But unfortunately, we're going to leave you right here on this video. And next video will obviously be a follow-up to see if we can get these parts made and see if we can get this hammer back running. But as always, thanks for watching and all the support. Appreciate you guys.